Hello everyone, welcome to the Style 3D Simulator Volume Axis Field Function course. Today's lesson will cover the following points. 1. Adding a volume axis. 2. Volume axis properties. 3. The impact and weight of volume axis field on panels. 4. Parameter adjustment techniques. 5. Using volume axis in sequence. Let's get started. There are 3 ways to use the volume axis field. 1. Add the volume axis to the scene. 2. Bind it to a body. 3. Bind it to a specific bone. Next, I'll explain the specific methods for adding a volume axis field. In Place Actors, search for Style 3D Volume Axis Field and place it in the scene. You can move, rotate, and scale the volume axis using W, E, and R keys. Select the character, click Add, search for Style 3D Volume Axis Field, and attach it under the body section. Select the root bone, right-click, choose Add Socket, and rename the socket. Open the character blueprint. Click Add, and add the Style 3D Volume Axis Field component under the main skeletal mesh. Set the parent socket to the renamed bone socket. Next, I'll explain the properties of the volume axis field. There are 3 types of fields. 1. Force direction. 2. Normal direction. 3. Hydrodynamics. Magnitude adjusts the overall magnitude of the volume axis. Attenuation adjusts the attenuation along the axis absolute distance. The value is the attenuation exponent. It can be understood as a hairdryer. The farther away, the weaker the wind, the closer, the stronger the wind. Volume speed attributes can be visually seen through arrows. By adjusting the value, you can enable directional force. The higher the value, the stronger the force. For example, setting the value to 0.1 enables directional force away from the axis. When multiple subrate fields are added, the vector sum of multiple fields will collectively affect the fabric. Turbulence-related parameters can adjust the fabric disturbance effects. Turbulence: the larger the value, the greater the fabric deformation. When using it, you can set one axis as the primary direction, with high primary axis parameters and low others. Turbulence speed: the larger the value, the faster the turbulence cycle changes, currently cyclical. The turbulence speed of each axis is also affected by the turbulence value. For example, if the x-axis turbulence is 0, modifying the x-axis turbulence speed has no effect. Turbulence frequency: the larger the value, the denser the waves. You can control the frequency of each XYZ axis separately, affecting the turbulence swing direction. When the axial frequency has a value, the fabric swings along the axis. To make the fabric wave along a fixed direction, increase the axial frequency, and turbulence speed should not be too high. Turbulence offset controls the current phase of the turbulence, affecting the initial position and trend of the current cycle. You can control the current phase of turbulence for each XYZ axis separately. The turbulence parameters also affect the initial turbulence direction, with positive and negative values corresponding to opposite directions. Hydrodynamics, suitable for simulating more intense wind. The drag force of the volume axis on the fabric. The lift force on the fabric along the normal direction. When enabled, the speed field previously set uses a new model for calculations. Next, I'll explain the impact and weight of the volume axis field on panels. The field weight painting is similar to attach painting. Switch the SMD property to field. Use a brush to paint the affected weights, 1 for 100% affected, 0 for not affected. After painting, save directly. Check Affected by Field to enable the volume axis to affect the panel. Select the volume axis and set which field weight map to use for the volume axis. Enable the strength and simulate. Now let's see the specific operation. Attach Style 3D and Style 3D volume axis field under body. Adjusting the volume axis parameters is quite complex, so you can use the UE simulation mode. During runtime, select the component to adjust parameters, and you can see the effects while adjusting. The effects after the parameter values stabilize for a while are closer to the real parameter effects. Adjusted parameters can be exported and imported using the parameters below for saving and calling. After completion, let's see how to use the volume axis in sequence. Add the Style 3D and Style 3D volume axis field tracks. Right-click Properties to add the corresponding parameter tracks. All volume axis parameters support setting keyframes in the parameter track. Add a camera and simulate rendering. Alright, we've finished our operation process. As you can see from the tutorial, the volume axis is more complex than the wind field component. It has more parameters, making it suitable for creating complex force field effects. The volume axis supports configuring the type, magnitude, direction, and range of forces, as well as turbulence. It supports the use of multiple volume axes simultaneously and can also be used in conjunction with the Style 3D wind component. Well, that's the end of our video for today. You are welcome to post, comment, and forward the video. See you next time.